Hello. Starting the day off strong, we have John Coene, author of JavaScript for R and the R series, a valuable educational resource and something our speakers later in the day might attest to with their JavaScript and Shiny topics. John is also the creator, author, and contributor of numerous popular packages such as eCharts for R, Ambiorix, Waiter, Grapher, Packer, Firebase, Cicerone, Sever, Marker, Globe4R, just to name a few. All of these resources and additional information can be found on John's personal website, john-coene.com, or his GitHub. Just look for the funniest profile image, and that's John. John also founded an independent data and programming company, OpenFX, which can be found at openfx.org. Last year, John joined ShinyConf to discuss Shiny app performance with dynamic endpoints. Today, John is presenting Scaling Shiny, sharing his experiences from building a large application in the pharmaceutical industry. John, welcome to the stage.
Hi there, thank you very much for having me, and thank you for the kind introduction. I assume you can see my screen. Can you see it?
Yes.
Lovely. Thank you very much, everyone, for attending. So as introduced, the topic is essentially scaling Shiny and experiences that we've learned building a very large Shiny application. So just a quick introduction on the topic. It's called Project X. It's a very large app that is a metadata-driven way of creating mock shells and outputs at Idorsia. So working on this with me, there is Matthew Brierley and Chris Ridley. They'll be in the chat if you have pharma-specific questions that I cannot answer, as I take care of them, or the technical bits and our application that we're about to explore. Just a bit about the tech stack that we use, if we can call it that. So essentially, we've got an AWS S3 bucket to store plenty of files. We have a MySQL database and a Pinnacle 21 that we use for the metadata. Then below that, you have Shiny, of course, a Plumber API. We do use SAS via Webserver quite extensively, actually. And then for the code itself, I have Webpack for JavaScript, SAS for styling, and the whole thing is deployed on what is now POSIT Connect. So those numbers I know don't mean much, but they might give you an idea of the extent of this application. So I have loads of packages, thousands of commits, merged plenty of issues, and the lines of code that I counted for this it's a bit horrifying, admittedly, but it works. So what I suggest I do at the speed of light really is try and make a quick demo of the application. So what you have here is the homepage of the application. It's our test app. You have just on the homepage top level information about the application and the study it's deployed for. So you have the project, the study, the delivery type. In the top right, you can see the total number of outputs that we're preparing in this deployment, and diagnostics, which I'll cover very briefly. Then below that, some information. One that's important is maybe the types that give you some idea as to what we're doing. Each output is of a certain type. We have table, figures, and listings. And then next to that, we have a little sort of tool to track progress as we create those outputs. So outputs can be marked as complete, so we know they're done. They can be in progress, etc. Then next to that, you have this button sync P21, which is essentially going to pull all the metadata from Pinnacle 21. We get the define, extract the metadata, update our database via this thing. But I won't show you that right now. One of the most important bit here is the table of contents, where you will see essentially a table of all the outputs that we're preparing with basically top-level information about each and every single one of these outputs. So there are 82 down here. And the idea here is just to be able to quickly browse them. So we have a quick search. So if I want something about adverse event, if I can spell it, I can just search like this. We're displaying 18 out of 82 events, outputs, that is. If we want to filter by a specific section, we're interested in efficacy data, we can just do it like so. Go back to all sections. If you want to edit an output, you can do it here, duplicate plenty of stuff. But another tab where that's probably more interesting is the one where you actually define what goes into this output and what makes up a table. So we have shortcuts here that'll navigate me to the specs tab where we define all of this. And here is a very typical example that was prepared to me by Chris for this demonstration. I can only go into so much detail, but essentially we have a basic table schema that we've kind of come up with, but you can fairly quickly understand. A table is comprised of a header, row groups that are comprised of rows, we have a footer, etc. One thing that I can show you here, for example, to show the things we can do since we're metadata driven, is if I hover a variable here, I can see in the tooltip some information about said variable. And below I can see a code list that gives me the code and decoded values. Another thing that I really appreciate about this screen is that I think we've done a good job on the presentation. All of these are inputs, but we don't want to overload the user with information representing too many inputs. So these inputs are simply toggled by clicking on them. So here, if I want, I can click on this, and now I can make a search, and I can change that to, say, ADSL age. It toggles other inputs that are relevant, that are dependent on that. Then if I want, I can click save. Everything you do on the app is working locally on a local object, and until you press commit, nothing reaches the database. So I can just click undo, and it's undone that. And what we can do is and essentially use these inputs to create the table that you're interested in, well, generally tables, but it can be figures that you're interested in. And then when you're ready, you can click this button. It allows you to preview the table. So I'm going to click, I think I got my password right. That serializes to XML, sends to SAS. SAS produce a PDF output, sends it back, and now we can have the preview in here. I can click on this to have it full screen, and as you can see, that we had 4 row groups, 1, 2, 3, 4, that are defined by these outputs. We have the X's here because it's a mock shell. This can be toggled here with this button. Since I have limited time, I won't show you this. I'll show you a brief thing that I think is very important and extremely useful in this project. It's the diagnostics. Since we're metadata driven, as this metadata evolves, we have the metadata changes, and then what we might use to build certain outputs, tables, etc., might become out of date or, well, just wrong. So for instance, these are basic examples that are forced in there to demonstrate. We then run diagnostics on this, make sure that what we have to build those outputs is actually available in the metadata. And here, for instance, we have a message that tells us that in a specific output we use the code, wrong code, which is not valid. If you look below, dataset ADS does not exist indeed. And so these are the kind of things we're able to do with the application. This is just a very handful of a small number of features that we have. So what I want to do is, because it's such a large application, just show you a bit, talk to you a bit about what I've learned building this. And before I do that, I need to mention a bit about how we work. As we've seen on the introductory slide, it's just the 3 of us, Matt, Chris, and I, who work on this as part of a small biotech company, Idorsia. And therefore, we have limited resources. That means that the approach that we have taken, which one could argue is wrong, but has worked for us so far, is very much one of rolling releases. That means that basically everything that's deployed in prod is pretty much bleeding edge. It's the latest version of the code that we have on GitHub. And unfortunately, well, it means we can move faster, but unfortunately, it means that, yes, perhaps sometimes there may be bugs in the code. However, I can confidently say that in the vast majority of cases, I'm able to close the issue and deploy a fix in production within a matter of minutes. And that's very much the approach that we've taken here. And so one thing that really enables me to do this is what's on screen right now. And if there is one thing I hope you take away from this, this talk is this very slide, is the idea of writing glanceable code. We often say that we read code, but I think it's a bit of a misnomer. We don't actually read code like you read a book, sentence by sentence, line by line, left to right. You don't read code, you glance at code. You scroll through it vertically, looking for something. And the idea is that if you can write your code in a way that you can glance at, then it's easier to find the things you're after. And here what I have on screen is just a simple example on that, but I would argue the code on the left is glanceable, whereas the one on the right is not. These are not things I've come up with. There's a link at the bottom of the slide on this idea of line of sight, which is this first tab indentation that is here, which is where you're kind of, your eyes are as you scroll through a file, and you're able to quickly sort of ingest information in what the code actually does by just keeping your eyes on this line. And two of the main tricks that help a lot, there are many, but is one, return early, like the code on the left here. I can see that if the argument is equals to fizz, return, it's dealt with, and then I can move on to the rest of the code. If it's buzz, then dealt with, and then I can understand why when it's something else is actually returned. On the code on the right, it's very difficult to glance at. So don't use else, for instance. You don't really need it, I think. The next thing we have, that one is quite interesting. It's somewhat akin to probably modules that you've heard before. But here we kind of take it a step further. Instead of just modularizing your code, you push it to a completely different package. And one thing that it does is it forces quite literally a separation of concerns in your application. Another thing that's really nice is it makes it vastly more reusable. So for example, the theming we have for the application that you've seen is all custom built on Bootstrap 5. That is part of a package that's now used and reused at Idorsia. Same for the filter, which is an interesting module I didn't show you, but that's used elsewhere. And another thing that's very important for me is very much the third bullet point there is it forces me as the developer, the writer of the code, to build a nice coherent interface to what I'm building, because it's a separate package. It has to make sense on its own. I have to think about the functions that I write, how I name them, and how they work together. Whereas when you generally have something that works on the internals, you're gonna cobble together a loose set of functions that more or less do what you want, but you're not gonna think about building an API per se. Then it's very easy to break down the project. So on the second slide on the tech stack, I showed you that we had a plumber API. We didn't have that at the start. We had the need for it. So, but thankfully, some of the stuff that was done, like the diagnostics, was part of an entire package on its own. And it was very easy to just take that package and, well, use it elsewhere. We didn't have to copy code or anything. And then finally, it genuinely makes it more manageable. Another one is this pet peeve of mine. Be really, really careful with reactivity. It's extremely easy to add and very difficult to remove. We quickly nest reactives. We forget that inputs are reactive, and so we have a reactive that uses an input. That reactive is itself used elsewhere, and so on. And then when you have a bug, you're in absolute hell. So one thing I suggest is to work the other way around. And something that I didn't do at the start of this project, but I certainly do now, is essentially when I have a reactive, any reactives that I use in there, I isolate. I use isolate everywhere, then remove it to make the code work and reactive. Don't work the other way around. It's too easy to forget an input or a reactive somewhere. And 3 months down the line, you find your app misbehaving, and it's very difficult to isolate. And as such, I thought what I was on this, modules ideally are self-contained. If you have a module where you pass a reactive to it and it returns another reactive that you pass to another module, then the module becomes more of a way to organize your code rather than an actual module in the strict sense of the term, in my mind at least. So be careful with that. And one thing that I do use extensively in this project is, I think, what was mentioned kindly by Mike in the introduction on my talk last year on endpoints with Shiny. And then that's my last slide. It's about, again, to reiterate, we're a small team. We have very limited resources. We can't reinvent the wheel at every turn. So we need to leverage external tools that facilitate the work so that we can actually make progress on what we're trying to build. Yet, I don't think that should stop you from building your own tools. Often an external tool will allow you to make 90-95% of what you do extremely easy, but a 5-10% that sometimes is crucial to make the feature really complete, absolutely impossible or very difficult. And I believe that in those cases, you shouldn't hesitate to build something custom. Like, for instance, when I showed you the table of contents, we used to have data tables there, DT, which worked fine for a while. But then with all the additional searches and interactivity we used, it started becoming a problem. And since it's such a crucial feature, we decided to build something completely custom from scratch, and it works like a charm. And so if I want to leave you with that last line there, it's something that I've seen too often in Shiny applications. When you build an application, you define the features and then you find the tools that help you build those features, and not the other way around. Don't think, if you find a new cool package that should do something interesting, don't include it for the sake of it, thinking that'd be a cool feature to add. Work it, again, the other way around. And on this, I'll thank everyone for attending. I hope you have questions. And again, if it's anything Pharma specific or on the app and what it does, please feel free to type it in the chat. I think we have Chris and Matt in there to answer you. Thank you very much.
Yeah, thank you for presenting. The diagnostic table looked really nice. I like that. That was a really good demonstration. We do have some questions in the chat. A lot of people are fans. Eric Nance, I think, also has some burning questions building in his mind. So you might get some messages on LinkedIn from him later.
Sounds good.
Yeah. So just to start off the question, what package are you using for connecting with S3?
That's a good question. If I remember, there are multiple ones. I think we use AWS.S3. I think there's something for PAWS, PAWS, I think, as well. But I think we use AWS.S3.
Great.
What we do is fairly simple with S3. It's just retrieving the files and uploading new ones.
And from Jack, we have, how do you obtain, this was early on in the presentation, how do you obtain figures like the lines of R code? And someone typed in underneath CLOC clock. Do you use something similar? This was for the slide of the presentation showing the lines of code.
Sorry, I might have missed that. The lines of code on the slides themselves.
Yes, you had a slide showing how many lines of code you used for the project.
I can't remember. I googled something and I got a Linux command on my Linux machine to count these.
Okay.
I can't remember quite what it does.
No worries. And yesterday, Philip presented an open source's influence on shaping the pharma industry in regard to OpenFX and how OpenFX operates. Can you share some additional experiences on how much open source, in particular R, plays a role for you and your clients on the projects?
That was a good question, and one I certainly was not expecting. Me creating this company OpenFX came from all the open source projects that I did. That's how I came to be known by some people, and that's how I got the chance to do that. So I still do that. The company has a GitHub, and I try and do when I find time plenty of open source stuff. And so most people approach me for these kind of things. And so, yes, I do use a lot of open source pretty much everywhere. People don't quite like closed source anymore, I think.
Mm-hmm. It seems to be the trend.
Indeed.
From Eric, we have a question. So can you share how you handled calling SAS from the application?
No, that's a good question, but I think maybe Chris can comment on that in the chat. But essentially, Chris Ridley, who again I work with on this. He's our SAS and standards expert, and he's managed to open an endpoint in SAS itself on the SAS Webserver. And essentially what I do then is serialize the data and I send it to his endpoint, and he just sends me back the data. It works like a standard API.
Interesting. From Andrew, we have, I'm getting comfortable using modules in my apps, but it seems as if designing a package, a truly self-contained module, can be beneficial for reusability. Do you have any recommendations on where to begin learning how to create a package for personal use?
Oh, that's a good question. I'm afraid I don't really, or I would have to recommend you the usual books on how to build packages. And to be totally clear, most of the packages that we've built, and on that slide that I had listing the packages, those do not contain, very few of those contain modules as part of packages. Generally, it's the underlying functionality that I'm trying to encapsulate into a package. Then how that package and that functionality is used within a Shiny application, it tends to be outside of this, essentially.
Interesting. And I think another question from Eric. So he's building a catalog here. When a new study wants to use the app, how difficult is the onboarding process, or is it general enough to apply to a new study out of the box?
Yeah, well, Eric also works at, well, he's at Eli Lilly. He knows Pharma and he knows how it is. So he's asking the good questions. For the first one or two, it was extremely painful, but eventually I found a way to make it easy. So the application was originally built as Golem, so it's a package to begin with. And then what I have is essentially so to deploy the application, you need some secrets in an R environment. And you need this is quite an extensive config file to tweak the title, the stuff, the path, directories, things like this. And then what I have is all of this in a GitHub. I think they call it a template. I think Eric knows what I mean because he uses that. And so it's essentially a repository that includes all the code with renv and that application installed, as well as how do you call it, a Git submodule for the API, and essentially then it's just really cloning that, changing the config file, and deploying API, and then the thing. And it was painful, but thankfully now we've had to do it so many times that we've kind of mastered it, I think.
That's great. From Isabella, what is your QC process when updating data and adding code? Additionally, how do you divide work amongst your team when managing the code? Because I remember you mentioned three people on the team.
Yeah. So, well, for the R code, for the app code, it's very much just me. Currently, at least, it's just me. So, in terms of managing this, there isn't so much. It's more again about I think managing the expectations and what we can achieve, given that there's just the three of us. And so in that sense, I'm afraid that question, we don't really do that too much, to be honest. Perhaps we should, but it's just, I write the code and I QC it, and it's often fine. It's kind of how it has to work, essentially.
Mm-hmm. There's some perks with smaller teams, which is good. From Paul, we have, what was the main benefit of developing this as an R app? Did you consider other technologies?
No, that's a good question. Again, maybe someone, Chris and Matthew, can help me in the chat. But I think it was mainly because it's a language that's already understood in-house. Admittedly, this is the kind of application where perhaps, at least at this stage, you could make the argument that R is not necessary. Could that very well have been written in something else? But at least that's something in a technology that Idorsia understands and can pick up eventually. Pick up, maintain, and understand all of that. Yeah.
Okay, great. And I think we have time for one last question. When building Shiny applications for production, are there any particular challenges that are somewhat unique to the pharmaceutical industry?
Oh, no, it's a bit of a loaded question. I think there's probably a lot. But thankfully, that's where I couldn't do this on my own. I really need Matthew and Chris to help me with navigating all this landscape that I'm personally extremely still today unfamiliar with. There are some things that I assume this person is alluding to, like validated environment and things like that. So a lot more rigorous. So yeah, we've encountered challenges. I would assume plenty, but I can't. I don't know. Nothing comes quite to mind right now.
No worries. Okay, well, John, thank you so much for presenting today, and thank you so much for answering the questions. If anyone has any chats, feel free to reach out to John.
Thank you, Micah. Bye-bye.